In this, I will show you how you can add your own movement component, and we will set up and connect the speed attribute. Let's start by adding our own movement component. I'll put it into the actors component folder, but you can create the one you see fit. To let character use our movement component, we're gonna have to grab the object initializer constructor from our actor file. Now we'll need to call setDefaultSubObject class with our movement component class as a template parameter, and then we'll specify the name of the movement component as a parameter. Let's move everything from the old constructor to the new one. Now it's time to add our movement attributes. We will definitely use stamina, so let's add it. And the last one we're gonna add should be the max movement speed. I'll show you later how we can use it. Now here we should actually apply the movement speed. First we need to get our owner as a character. Then its movement component. We get the attribute value, And then there is a parameter on character movement component called max walk speed. It is used for the walking movement mode as a cap for the speed. During the movement, the character fastly increases the speed until he reaches this one. So by changing it, we will change the speed at which we should move at the moment. Now we have to add the corresponding modifiers to our default effect. Let's see if it works. Yeah, as you can see, we have all the attributes set, and we also got this moonwalk. That's because 350 limits our speed too much. Let's set it to something bigger, like 500. Yeah, as you can see, 500 allows us to run normally and reach the correct animation on the blend space, because it's also based on our velocity. Now you can manipulate your character's speed by gameplay effects or even many gameplay effects at once. For example, some speed potion can increase the speed by 10%, while some debuff can decrease by 20%. With this attribute-based approach, we can now implement something like this. Later, I'll show you in practice how it will work. The multiplayer test also shows that everything works fine. The most common approach to implement movement animation is to have a blend space that is driven by a velocity. It is network friendly and fail-safe. Right now we have a linear blend space that can handle only forward movement, as we interpolate only between forward animations. This is possible because we always orient our character rotation to movement. You can always type p.visualize movement 1 to see the acceleration, aka our input direction, and the velocity direction. As you can see, our character always facing the green velocity direction. But if you would like a character to look in the same direction as we are looking, for example for shooting, we're gonna need a so-called strafe blend space. The one like that we'll implement and connect today. First of all, let's create an asset and select the correct skeleton. Let's call the horizontal axis just side and set the range from -600 to 600 and the division amount to 10. The vertical axis will be called forward with the same values. Now we have to put our animations. Roughly speaking, the side and forward represent the speed with which we are moving in that direction. The faster the speed, the bigger the value, the more we blend into faster animations. So the fast animations with faster movement should be put at the bigger values. You can always press Ctrl to see how the animation will play at a certain position. For now, we'll just set walk and jog animations. Alright, now we have to connect our blend space in the animation blueprint, because previously we have only one axis and we have now two. And we'll need another calculation for it. To see what actors we have on the scene, you can always press F8, then select an actor. This is how I'll locate the animation blueprint. We need the parent class. And by the way, as you can see, we have an idle state here, so we can remove it from the blend space. Let's find our animations. And remove the idle from the blend space. Then first let's put the new blend space. We'll need two variables for each axis. Now, in the event graph, we'll have to add a calculation for them. We're gonna update them on tick. We see mostly the same result because we have orient rotation to movement set to true. Let's change it to use controller desired rotation instead. Finally, as you can see, now our character can run to the side but will always face our view direction. In future, during the gameplay, we will switch between these two modes, for example, for free movement and shooting. This is a very handy feature. For now, let's just switch it back. Right now we have all our animations hard-coded in the animation blueprint, but in real production you might want the animation selection to be data-driven. We will implement this today. First of all, let's create our custom anim instance class. we will need a similar approach as we used for a character, and first create a specific data class. First field gonna be the reference to the blend space. The second one will be the idle animation. Now let's add the data asset for this newly created structure. As with the character data asset, we will just add our new structure as a field to set up. We'll need a folder just for anim data asset. Now let's create the asset. Let's open it and set the reference to our already existing assets. We will have to some way connect it to our character, and because every character should have some default animations, let's just add the reference to our data asset to the character data. So we'll be able to set up any character with one asset. Let's set the reference now. Now it's time for our anim instance. We're gonna need to add a few getters for our animation data fields. First, let's get our character. Then we'll need its data. And if it's valid, we'll access it and return the blend space stored there. Otherwise, just null. Let's do mostly the same for our idle animation. Now we have to change the parent of our existing animation blueprint to our newly created one, and then use the newly created functions. We can expose the blend space as a pin. Yeah, our getLocomotionBlendspace function. Let's do the same for the idle. It doesn't want to connect because looks like we need an animation sequence, not the anim asset reference. Let's quickly change that. Now it works fine. Let's test it. It works great, but we still have the T-pose artifact in the editor. To fix this, let's add some default anim asset reference right to the anim instance, so we'll never return null PTR, at least if it will be set. We have to set the reference and recompile. Yeah, now it looks fine. With this approach, you can now easily set up your character animation just by switching the animation data asset. This would work great if you want different locomotion animations for a human and, for example, some giant troll. Or you might want those animations to be driven by the equipped weapons. We'll return to this later during our course. In this short lecture, I'm going to show you the trick with physical materials. I do not pretend that this is the one and only way how you should work with them, but as part of this course, it might be very informative. We will create our own physical material class that will be able just to tell us the required information by himself. Let's create the class. So imagine we've made a footstep and we want to know which sound or VFX to play for this material. Well, our smart material will be able just to tell us. Let's add the sound for now. Now let's create a folder for our materials. First, let's add the default one. You can see here is our sound. And this field called surface type can also be returned to serve as an additional material identifier. Here we just leave it as is. Now let's add the wood physical material. For wood, we will actually add a new surface tab. Now we'll have to assign our physical materials to the existing materials. We can just assign the material to an object right now. In this lecture, we will implement the footsteps component that's gonna be using recently implemented advanced material. First, we have to create the component class. Because the moment of the footstep depends on the animation, we will need a specific notify that will trigger at the right moment. So let's create the notify too. We have to add our footsteps component to our character as a default subobject. For the footstep notify, we will need an enum to specify which foot, left or right, it is. Depending on that, we will later consider different foot socket for our calculations. We don't need tick here. What we need here is the public function that will handle the footstep. Inside, we'll first need to get our character. And its mesh component. Here, we'll be able to get the foot socket location depending on our foot enum. We'll have to add socket names as parameters. To test if the footstep did actually happen and on which surface, we'll have to perform the line trace. First, let's set up the query params. We needed to return the physical material. And let's add our own character as an actor to ignore. We don't want the footstep trace to hit character's foot. Now the exact trace. We'll use the world static trace channel. Let's try to get our physical material. And here we will play the footstep sound specified in that material. A very good practice that I highly recommend is to add some debug drawings or logs at the time of development to see what's going on with the feature. Trust me, this will save you a lot of time later during the debug. So let's add the console variable that we're gonna use for debug. In case the debug is turned on, we're gonna show the name of the material. In case we don't have a blocking hit at all, we'll just show the red line which represents our trace. Now it's time for our notify. It will have to trigger that handle footstep function on our footstep component. We can get the character from the mesh component. Let's create a getter here, so the notify will be able to access the component. Finally, here we will ask the component to handle the footstep for the specific foot. We will have to add it as a property. Now the boring part. We will have to add footsteps to our animations. The task is to add a footstep notify each time the foot touches the ground, with specifying which foot it is. On the video I will skip the rest, but you'll have to add those for all your movement animations. Here we have our socket names. For now, let's just add the correct names here, or you can make the component editable in the editor and specify them there. We have to add footstep sounds references inside our materials. Let's recompile. If you've done everything correctly, you should now hear sounds of the footsteps. Let's see what the debug will show to us. Yeah, as you can see, we have the material correctly identified for each step, and every step has the correct location. One more thing. Over here, let's use the save function to get the name in case the material is null. Yeah, now as you can see, it just shows none and does nothing for the non-identified materials. If you wish, you can add some sound to play there just by default later. As you know, before Unreal, we always had input mapping defined in settings. We could set up axis and action mappings here. But what if, for example, during the gameplay, you would like that input to be differently detected, give different input and key bindings? So to make it context dependent, well, that's where enhanced input comes to the stage. To start using it, we first have to enable the plugin. Let's restart the editor. Now we have to set the base input classes to the enhanced input ones. Let's create a folder for this feature. First, we'll create the context asset. This asset represents the old mappings, but as an asset that can be pushed to be used when needed. As you can see, it looks similar, but in this case we have just a general mapping section. Now let's create the input actions. With this plugin, each of them will also be represented as an asset, with some options to set up. We might want to receive a float here. Now let's start adding our actions to our mapping context. The negate will give us the negative value, which for us will work like an input to the opposite direction. Time to go to C++. First, let's add the public module dependency. Now let's add the references to the newly created assets for our character VAU properties. We will also have to create new functions to handle the input because we have to receive the f input action value as an input this time. Let's declare them. We can just take the existing code from the old input mapping. The difference will be in a way how we get the exact value. Here we're gonna need to bind our functions, but this time in a new way. And in order for all this to work, we will have to exactly use our context. We're going to use pawn client restart function for this. You have to do it via the enhanced input subsystem. First, we clear all mappings, and add our context with the priority 0. Let's set our references. Looks like I forgot the super call here. Yeah, it works, just as before, which means for us that we have successfully moved to the new enhanced input plugin. In my case, I have some input directions inverted, so let's fix them. Now it's time to do a little cleanup, because we won't need the old code. As you can see, originally we were detecting jump action at both start and stop. So let's do the same with the enhanced input. Here we also can get rid of the unnecessary code. Now we have the enhanced input fully configured for our existing needs.